Janok, is it a long way to go to link the outcrops in the modern systems, or how good we are at deciphering the outcrop?
Funny you should ask that. So I just reviewed a paper today on a well-known Asian delta, and in my review, it was a good paper. Wait, that plane's fast.
Yeah, let's drink.
All right, it was a good paper, but you know, when you look at the modern systems, depending on how deeply you get into them, you know, if you just look at the superficial sediments, the question always becomes, what relevance is a thin superficial layer of sediment with respect to what gets preserved in the stratigraphic record? So this paper was trying to make the point that the Mahakam is in transgression right now, and the distributary channels are backfilling, and I'm like, okay, that's great, but you've got, you know, maybe 20 meters of transgressive distributary channel fill. You've got a 15-meter thick prograding edifice. So if that gets preserved in the record, let's say that, you know, you remove 10 meters by transgressive erosion at the end of the day, so you preserve 50 meters of the progradational phase and 5 meters of the transgressive phase, well then 75% of the delta is still the regressive phase. So I think this notion of what gets preserved in the stratigraphic record is an important one. And studying modern systems is important, you know, and if you understand what's likely to get preserved, you can look at a modern map of, say, a delta system, which is what I work on, and say, well, you know, during a transgression, how much of that is going to get whacked off by waves, you know, and you can estimate maybe it's 5 meters, maybe it's 20 meters, maybe it's no meters, you know, and then you can go to the rock record and say, right, is there evidence that this is a top truncated system or top preserved system, and get into this issue of preservability. You know, one of the differences between my research and other research, and a personal thing, that a lot of the facies architectural work was done in river systems in which the channels are always eroding into the floodplain and one channel cuts to another. But in deltas, you essentially have a hole that passively fills. It's actually harder to erode, so you're more likely to preserve more of the original depositional system in a delta than you are, say, in a river, because you've got so much more erosional processes. So, you know, the understanding the modern, when I look at the deep water guys, it's even better because, you know, when you've got this infinite accommodation of deep water systems, you have even greater preservation potential of a lot of your systems, you know. Submarine channel levee complexes can build up 1,000 feet of depositional relief. Deltas and rivers can't do that. So you know, I think that the guys that study deep water systems have demonstrated the value of modern analogs to understand the ancient. It gets more difficult when you start dealing with lower accommodation settings or settings in which you have more erosive processes like tides or rivers.